Welcome back to my channel, dear guys. Now, on yesterday's lecture, I have introduced the concept of various forces existing in nature. Okay, and I also discuss about few important terms related to gravitation. Okay, and there I told about what is gravitational field, what is intensity, and what is gravitational potential. These terms. Okay, now in today's lecture we shall discuss about the acceleration due to gravity. Acceleration due to gravity. Okay, now what is it? We know that earth is attracting every objects or every bodies towards its center. Okay, now suppose this is the center of earth. Okay, this is the center of earth, and an object of mass m is located at a distance equal to the radius of earth. Okay, that means this is the center of earth. Okay, m is the mass of earth, we all know, and capital R is the radius of earth. An object of mass m is located at a distance equal to the radius of earth. Now what will be the gravitational force of attraction between the two bodies? That is simply g into m by r square. This is the gravitational force of attraction. Okay, and this is equal to the own weight of the object. What is the own weight? That is m into g. So these two forces must be equal. Okay, the gravitational force of attraction is equal to the own weight of the body. Okay, so from which we can easily write g, this is equals to gm by r square. Okay, so this is obviously at the surface of earth. Okay, this is obviously at the surface of earth, but if the object is located at a height, say h, from earth's surface, then the distance will not be r. Okay, it will be r plus h. So this is the acceleration due to gravity at the surface of earth. Okay, this is the one thing. Now before proceeding, we have to know few other things, few numerical things we have to know. The first thing one have to know that the mass of earth, we have to calculate these numerical values. First of all, we have to calculate the mass of earth. How we can calculate this? By using the formula that I previously wrote, that is acceleration due to gravity at the surface of earth. We all know acceleration due to gravity at the surface of earth, this is simply g into m by r square. So from which we can easily calculate m. So what will be it? G r square upon g. Okay, so what are the values? G SI unit, G is 9.8 and R is 6400 kilometer into 10 cube meter. That means this whole square. And what is G? We all know 6.6 into 10 to the power minus 11 SI unit. Okay, so this is obviously in kg. Okay, so if we substitute these values, then the mass of earth will exactly become 6 into 10 to the power 24 kg. So if you put these values in calculator, then the result will be exactly 6 into 10 to the power 24 kg. So this is the mass of earth. Okay, it's simple. Now the second thing we have to find out the density of earth. Okay, the second thing we have to find out, that is mean density of earth. Mean density of earth. How we can calculate this? Okay, now why mean density? Because we all know that the shape of earth is not perfectly spherical, not exactly spherical. Okay, the equatorial region is extended and the polar region is little not so extended like equatorial region. Okay, so the shape is just like this. Okay, the equatorial region is extended but the polar region is not so extended, so the shape is not perfectly fair. So there are different densities in different places, so that's why we take the mean density. Okay, so shape of earth is not perfectly spherical. Okay, the shape of earth is not perfectly spherical. Okay, the shape of earth is not perfectly spherical, so that's why we have to calculate the mean density. What is it? Okay, that is what the mean density is given by. Okay, so how we calculate? We know that mass, this is equals to volume into 4/3 pi r cube rho. This rho is mean density. Okay, because we take the earth as a homogeneous sphere. Okay, but actual shape is not sphere. Okay, so that's why we use the term rho, mean density. That's why we call rho as mean density. So this is the mass 4/3 pi r cube into rho. So what will be my rho? My rho will be 3m by 4 pi r cube. So what will be my m? We calculate it 6 into 10 to the power 24. And what is r? We all know that is 6400 into 10 cube. This is obviously kg per meter cube, and if we put it, the result will be 5.4 into 10 cube. Okay, so this is the mean density of earth. If we put these values in calculator, then the mean density of earth will be 5.4 into 10 cube kg per meter cube. Okay, now the third thing we have to calculate, the mass of sun. Mass of sun. Okay, so which formula we can use? We use the gravitational force of attraction between sun and earth. So let us take the example of sun and earth, because we for earth we know all the data. Okay, so what is the formula? The gravitational force of attraction between sun and earth. This is m sun, this is earth, and this is r square. This must be equal to the necessary centripetal force, mv square by r. Okay, so m cancels. Fine. So this is simply gms upon r square. This is simply what is v? V is nothing but 2 pi r upon t. So what is it? 4 pi square r square by r into t square. Okay, so 1 r cancels. So what will be my g into ms upon r square? This is simply 4 pi square r by t square. So from which we can easily calculate ms. So what would be it? 4 pi square r cube by t square g. Now we have to put the different values. Okay, now for earth we all know the value of different quantities. Okay, I will not erase it because I require. Okay, so the mass of sun the formula is 4 pi square r cube by t square g. Now what is the distance between earth and sun? That is 15 crore kilometer. That means 15 into 10 to the power 7 into 10 cube meter in meter. That means 15 into 10 to the power 10 meter. Okay, and what is the time period of revolution? That is 365 days. Okay, that means this in second. Okay, so we have to, if we put these values, then what we get? 4 into 3.14 whole square and 15 into 10 to the power 10 cube upon t square. That means 365 into 86,400 whole square into g, 6.6 into 10 to the power minus 11. Okay, so if you put these values in calculator, then the result will be 10 to the power 30 kg. So this is the mass of sun. Okay, this is the mass of sun. Okay, if you substitute the value of different quantities, then the result will be this 10 to the power 30 kg. Okay, so the mass of sun is of the order of 10 to the power 30 kg and the mass of earth is of the order of 10 to the power 24 kg. Okay, so we have calculated few important numerical things, that is mass of earth, density of earth, mass of sun. Okay, now one thing, that factors affecting, our next lecture is on the factors affecting g, because g will not be same at every place. So let us now see what are the different factors that affects the g, that is on what factors g depends upon. Okay, so g changes with altitude, this is the first thing. Okay, next thing is the depth, and the next thing is effect of earth's rotation, effects of earth's rotation. Okay, that is diurnal motion. So these are the three factors that mainly affect the g: altitude, depth, and effects of earth rotation. When earth rotates about its own axis, okay, we in 24 hours it can affect the g. Okay, so how these factors will affect g, that we will do in the next class. Okay, so ultimately these are the three factors that can affect g. G can vary with altitude, depth, and effects of earth rotation. Okay, so this is up to for today. Now in my next lecture I shall discuss how these factors can affect g. Okay, so if you don't subscribe my channel, then kindly subscribe it to get latest videos on physics. Okay, thank you.